Hello everyone and welcome. My name is Sydney Howlett and I'm so excited you're joining me for today's session, Speak for the Trees. I'm a former classroom teacher from Ontario and have the pleasure of working as the engagement manager for GreenLearning. For those of you who don't know, GreenLearning is a national not-for-profit organization that creates free online resources about climate change, energy, and the green economy. Our mission is to engage and inspire students like you to create a positive change in our world. As I mentioned, I'm tuning in from Ontario. I'm so grateful to live and work on land covered by the Haldimand Treaty that was granted to the Six Nations of the Grand River. I am located on the traditional lands of the Neutral, Anishinaabe, and Haudenosaunee people who care for these lands for generations. So what are we here to learn about today? Well, we're going to be exploring how you can join the movement to fight climate change by changing some of your daily energy habits. By the end of this session, I hope that you're able to describe the connection between energy use and climate change, that you can calculate your own energy use in kilograms of greenhouse gas emissions, and that you can relate that energy use to the CO2 absorbed by trees. Before we jump into energy, it's important that we're all on the same page about a few things. To help me explain what is climate change and what's causing it, I'm going to pass it over to my man, Bill Nye the Science Guy.
We hear it so much that it feels like a buzzword, but it is far from it. Climate change is a real and serious issue. But isn't the climate always changing? What exactly is climate change and why should we care? Well, the Earth's climate has changed throughout history. Most of these slight changes are caused by small variations in the Earth's orbit. But climate change as we know it today is characterized by an abrupt increase in the Earth's temperature. It is estimated to have gotten 1.2 to 1.4 degrees Fahrenheit warmer in just the last century. 10 out of the last 13 years were the warmest on record. 97% of climate scientists agree that this new tendency is not caused by the variations of the Earth's orbit, but rather very likely caused by human activities. That means you and me. And since the Industrial Revolution, we have come a long way. Humans built airplanes, faster cars, developed remarkable technology, and learned how the natural resources around us can be used for our benefit. Although this has led to many wonderful inventions and advancements, like the device you're using to watch this video, or the ability to take a plane halfway around the world, it also means we've increased our consumption of natural resources and in turn released a lot of greenhouse gases into the atmosphere. Now, greenhouse gases occur naturally, but in excess can be dangerous to our planet. Modern human activities have increased the release of non-naturally occurring greenhouse gases because we have stepped up our demand for burning fossil fuels. The composition of greenhouse gases traps heat radiated from the sun. The more heat they trap, the warmer our planet gets. And as our planet gets warmer, we begin to feel the effects. One of climate change's biggest victims is our oceans. Oceans regulate the Earth's temperature and provide 50% of the Earth's oxygen. Now, climate change has increased the global temperature of the oceans by more than 0.3 degrees Fahrenheit since 1969. Although a warmer ocean might seem inviting to a beachgoer, it actually has devastating consequences for supporting life at sea. One of those consequences is ocean acidification, a direct effect of increased dissolved CO2. Since the late 18th century, ocean surface acidification has increased by 30%. A higher acid content means calcifying species, like oysters and clams and shallow water corals, are at risk, putting the entire ocean food web at risk. This is bad news for the 1 billion people relying on the ocean as its primary source of protein. Climate change has also caused the sea level to rise. Just in the last century, sea levels have risen 6.7 inches, but the rate in the last decade has nearly doubled. Sea levels have risen because as the ocean gets warmer, it swells. On top of that, glaciers and ice sheets are melting. Antarctica lost 36 cubic miles of ice between 2002 and 2005, and since 1994, each year on average, the Earth has lost 400 billion tons from its glaciers. That's like an ice cube 7.5 kilometers on a side, 4 miles on a side, melting and flowing into the sea. When all that ice melts, it fills up our oceans, and just like filling up a bathtub, the shores can't hold all that water, and coastal regions get flooded. Troubling signs of climate change are increased extreme weather events. Natural disasters like floods, tornadoes, and deadly heat waves are more obvious to humans because of their immediate impact and their sharing of the images in the media. Climate change, as we know it today, is change in our Earth's overall temperature with massive and permanent ramifications. Although its consequences can be planet-threatening, scientists still believe there are things we can do on a personal level to help. Recycle and reuse things. Walk or use public transportation to get to work. Turn off your electronics when you're not using them. Eat less meat. While you're at it, eat more locally grown vegetables and foods. And last but not least, spread your knowledge and concerns about climate change with others. When it comes to climate change, the main takeaway is that it's real. And although we are part of the cause, we can also be part of the solution.
Now that we know what climate change is and some of the risks to our environment, such as our oceans, it's time to get to work on what we can do to be part of the solution. One of the main ways humans create greenhouse gas emissions, which as we know contributes to climate change, is through our electricity use. From making energy to transporting it to our homes, schools, or businesses, and then using it, electricity can have a big carbon footprint. So how do we measure energy? Well, just as we can measure distance using a tool such as a ruler and units such as centimeters, we can measure energy the same way. The tool we use is called a watt meter, and the units, watts. Watts are essentially a measure of energy flow. Want to see how it works? This watt meter can measure the energy flow of any appliance or device that plugs into a standard outlet. Let me show you how. First off, I plug my watt meter into the outlet. Next, I take my device, such as a kettle, and I plug that directly into my watt meter. As you can see, my watt meter is currently reading 0, which means there is no energy flow. But watch what happens when I turn my kettle on. Already the watts have jumped up. The energy flow to my kettle is about 1,450 watts. Let's check out some other devices. Let's test out my TV. Give a thumbs up if you think it's going to take more energy than the kettle, or a thumbs down if you think the watts will be less. Let's check it out. So I'm plugging my watt meter into the wall again, and I'm plugging my TV into the watt meter. That's interesting. It's already drawing power. This is what we call a phantom load, which means that even when the device isn't on or in use, it's still drawing power. Let's see how this number changes when I turn the TV on. As you can see, my TV takes significantly less energy to run than my kettle does. Let's check out some other devices. You're probably wondering about some of the devices that you use most often in your daily life, such as phones, tablets, and computers. Well, let's take a look at some of mine. I have an iPhone. Watch what happens when I plug my iPhone into the watt meter, which is already plugged into the wall. So my cell phone uses very little energy. Watch how that changes as I start to use my cell phone. So it jumps up to almost 6 watts when in use. Next, let's check out my iPad. Now, this isn't always the case, but generally speaking, newer devices are more energy efficient, which means they can do the same thing but draw less energy. Plugged in, my iPad uses about 3 watts. Last but not least, let's take a look at my laptop. So my laptop is plugged in and it's on and running, and it uses about just shy or over 40 watts. Now this number will change depending on what I'm doing with my computer. Using internet obviously draws more power, so that number is going to go up. When it's off, it'll go down. But whenever it's plugged in, it's going to be drawing power, whether it needs it or not. And that's why it's so important that we not only turn off our devices, but that we unplug them so that we can avoid the energy loss through phantom loads. You're probably wondering, what does all this have to do with the environment, climate change, and my greenhouse gas emissions? Well, I'm about to show you a calculator that's going to take the information we just looked at, the watts from our devices, and help us calculate how many kilograms of greenhouse gases we're emitting through using those devices. Let's have a look. To access the Energy Calculator, head over to GreenLearning's Energy Revealed program and click on Energy Calculator, or type in the URL you see on the screen. To calculate total electricity used, the environmental impact, and the financial cost of using a device or appliance, you need the watts of that device and how many minutes per day the device is used. For example, remember my kettle used about 1,450 watts, and I use it on average 10 minutes a day. That means over the course of a year, my kettle uses the equivalent of 88 kilowatt hours of electricity, 7 kilograms of greenhouse gas emissions, and costs between $8 and $18 depending on what time I use it. Let's look at my TV use. Remember my TV used about 95 watts while it was on. Let's say my TV is on for 2 hours a day. That's equivalent to less kilograms of greenhouse gases per year than my kettle. But unlike my kettle, when it's not on, my TV has a phantom load of about 17 watts. If I do the same calculation with the phantom load for every minute of the day I'm not watching TV, it's equivalent to more greenhouse gas emissions than actually watching my TV. By unplugging my TV when I'm not using it, it could avoid 11 kilograms of greenhouse gas emissions every year. You may have noticed that this energy calculator is specific to Ontario. We also have an Alberta calculator. Let's see how the 7 kilograms of GHGs from my kettle use differs if I lived in Alberta. Wow, what a change! This difference is because of where these different regions generate most of their electricity. Here in Ontario, most of our electricity comes from nuclear energy or hydroelectricity. In Alberta, over 90% of electricity is generated from the combustion or burning of fossil fuels. If you aren't in Alberta or Ontario, choose the calculator that best matches your electricity generation. If you want to learn more about this, educators can check out the lessons, activities, and simulators from GreenLearning's Re-Energy program, or reach out to us at programs@greenlearning.ca. As you can see, we can calculate exactly how many kilograms of greenhouse gas emissions we're emitting into the atmosphere just through our energy use. Imagine if you calculated this for every single thing you use in a day, from waking up with your alarm to the energy used to warm your shower water or cooking your breakfast. Once we understand where our energy use is, we can take steps to reduce it or conserve energy, such as unplugging devices that we aren't using, playing outside instead of watching TV, or choosing energy-efficient appliances when we can. Another solution to reducing our carbon footprint is by taking those greenhouse gas emissions, or carbon dioxide, out of the atmosphere. While the ocean takes on most of that load, trees also breathe in carbon dioxide and breathe out oxygen. How many trees would it take to balance out your energy use? Well, on average, a tree can absorb about 21 kilograms of greenhouse gases per year. But that depends on the size, age, and type of tree. Using the worksheet provided in the description of this video, it's time to head outside and calculate just how much carbon dioxide the trees in your schoolyard can absorb in a year. You're going to need string, measuring tape, and your handout for this activity. Measure the circumference of the tree at about chest height. Record all the relevant information about each tree you find in your schoolyard on your handout. This information will help you calculate how much CO2 that tree can absorb in a year. Once you've gathered all your information from outside, head over to mytree.itreetools.org for the next step. Once you've navigated to the website, you can click Get Started. Search for your region and province in the search bar, and then you're going to input information about the trees. You can give your project a name, what type of tree is it, the species which you can search, the tree's condition, and if at any point you have questions about this criteria, click on the question mark on the side for more information. The trunk size, you can flip between diameter or circumference, where it's located in the sun, how close it is to a building, and a label for that tree. Once you've completed that, click Get Your Results. You can look at the information by tree or calculate it for all the trees you've input. Let's take a look at my specs. As you can see, my annual CO2 equivalent of carbon dioxide is 6.43 kilograms. Let's put this all together now for some real environmental action and host a School Earth Hour. Do more than turn off the lights this year. Use these calculators to track exactly how much electricity, greenhouse gas emissions, and money you'll be saving your school and getting closer to balancing out your emissions with the trees. Clubs and classes are both invited to register for our School Earth Hour Challenge for prizes of up to $1,000. Thank you so much for joining me for this session, Speak for the Trees. If you're looking for more lesson plans, games, or digital tools, educators can head over to greenlearning.ca or email me at programs@greenlearning.ca to continue conserving energy and taking climate action at your school. Thanks, and I'll see you next time.